Welcome to Eureka Math. I'm Mr. Schenkel. This is grade 8, module 4, lesson 12. Here we go. Emily tells you that she scored 32 points in a basketball game. Write down all the possible ways she could have scored 32 with only 2 and 3-point baskets, no free throws. All right, well, let's think about this and get some ideas. Maybe I can use my pen. Let's see. If she makes, let's say she makes 0 3-pointers. If she makes 0 3-pointers, I still have to account for 32 points. Each bucket would count 2 points, so that would be 16 2-point baskets would give me 32 points. So that works. Let's see. What if she made 1 3-pointer? If she makes 1 3-pointer, 32 minus 3 is 29. That's an odd number, so I can't make that happen with only 2-point baskets, so 1 doesn't work. What if she makes 2? Well, that's 6 points, and 32 minus 6 is 26, and then that would be 13 2-pointers. And then I see a pattern, so I'm just going to start counting by 2, 0, 2, 4, 6, 8, 10, and hopefully this will work out by just dropping the number of 2-pointers, 3 2-pointers at a time. So this would be 10, 7, 4, and 1. So let's just check one of these and see. 10 2-pointers, that's 20, and 4 3-pointers, that's another 12. So 20 and 12 is 32. So there they are. Those are all the possible ways that she could have scored 32 with only 2 and 3-point baskets. And then we need an equation. So what we're going to use is a standard form equation where every 2-pointer is worth 2 points, so 2x. And then we're going to add that to all the 3-pointers, which are worth 3 points, so 3y. And we'll set that equal to 32. So there's our equation, and this will work if we just choose any of these. Let's say we had let's choose this one, 4 2-pointers. Well, I could plug that 4 in for x, and that would give me a new equation. It would be 2 times 4 is 8 plus 3y equals 32. And then we could solve that to figure out how many 3-pointers she would make. So if I subtract 8, that gives me 3y equals 24. And then divide each side by 3. And 24 divided by 3 is 8. And it does give us that y value, if you will. Remember, x value is our first column, y value is our second. So what we're finding here is that the solutions to this equation in 2 variables is an ordered pair, x, comma, y. Each one of these is a solution. When x is 16, y is 0. When x is 13, y is 2. And so all of those ordered pairs are solutions to this equation. Okay, let's try that in a table here where they give us the linear equation in standard form, x plus y equals 3. And we're going to fill the table out. I can choose a value for x, or I can choose a value for y. It really doesn't matter what I choose. I'm going to make sure that I put some negatives in here for my inputs. So that I'm not fooled by different types of equations that we're going to see later on. So the first one, though, I'm going to try is 0. I think 0 is probably the easiest one. What I'm trying to do is make this calculation as easy as possible. So if I put a 0 in for x, I get 0 plus y equals 3. And that's just y equals 3. So if x is 0, y is 3. And that's my first solution. And it's the ordered pair 0, oh my goodness, 0, comma 3. Well, something like that. You can just imagine that that's a 3, since it's not working. What if x is 1? Well, that's 1 plus y equals 3. subtract 1 from both sides, I get y equals 2. How about a 2? 2 plus y equals 3. Subtract 2 from both sides, I get y equals 1. So a couple more ordered pairs. 1 comma 2 is a solution, and 2 comma 1 is a solution. Okay, and then I'm going to put some negatives in because I want to make sure that I consider a negative x value and see what that does to my y. It's not going to affect us now, but it will later, so this is a good habit to get into. Put a negative 1 in for x plus y equals 3. Add 1 to both sides, I get y equals 4. So that ordered pair is negative 1 comma 4. That's a solution. And let's try negative 2. Negative 2 in for x plus y equals 3. I'd have to add 2 to both sides, so y would be 5. So that's my next solution. There's an infinite number of solutions, obviously, because I can choose an infinite number of values for x. All right, number 2. 2x minus y equals 10. We're going to do the same thing. I'm going to start with a 0. And if I put a 0 in there, that's 2 times 0 minus y equals 10. So let's see, 2 times 0, that's 0, and I get negative y equals 10. Well, that's not what I want. I don't want to know what the opposite of y is. I want to know what y is. So I'm going to show you the math here first, and then we can shortcut this. So this is a negative 1y, if I could think of it that way, and then I would just divide by a negative 1 to clear that negative 1 out and do that same thing to the other side. And then I get y positive equals 10 divided by negative 1 is a negative 10. So negative 10. But I really don't have to do all of that. I can go back and say, well, if the opposite of y is 10, then y must be the opposite of 10, negative 10. And we'll do that so we don't have to do all this calculation. Let's put a 1 in for x. This is 2 times 1 minus y equals 10. That's 2, so I'd have to subtract 2 from both sides. I get negative y equals 8, so y equals negative 8. Put a 2 in. 2 times 2 minus y equals 10. 2 times 2 is 4. I would have to subtract 4 from both sides. Negative y equals 6. So positive y equals negative 6. All right, and then let's try some negatives just to be careful. 2 times negative 1 minus y equals 10. And 2 times negative 1 is a negative 2. I would have to add 2 to both sides. So negative y equals 12. So y equals negative 12. And then finally a negative 2. 2 times negative 2 minus y equals 10. 2 times negative 2 is negative 4. I would have to add 4 to both sides, so negative y equals 14. And then y equals negative 14. Let's just put the negative 14 in there. So those are my solutions. Remember, they're ordered pairs. The first one is 0, comma, negative 10. X then y. 1, negative 8 is a solution. When x is 2, y is negative 6. That's a solution. When x is negative 1, y is negative 12. That's a solution. And then the last one, negative 2, negative 14. All solutions for that linear equation in standard form. Okay, number 3. This time x plus 5y equals 21. Well, I can put a number in for y. I can put values in for the y variable as well. And if I put a 0 in for y, that makes my calculation easier, right? X plus 5 times 0 equals 21. Well, that's 5 times 0 is 0, so x equals 21. All right, so if x is 21, y is 0. And I'm just going to make decisions based on what's going to make the calculation easier for me. Let's put a 1 in for y. X plus 5 times 1 equals 21. This is x plus 5 equals 21, so I'd have to subtract 5 from both sides. That gives me x equals 16. How about if y is a 2? X plus 5 times 2 equals 21. That's x plus 10 equals 21. I'd have to subtract 10 from both sides. X would be 11. Okay, what if my y is a negative? Let's check that. X plus 5 times negative 1 equals 21. That's a negative 5. I would have to add 5 to both sides. That would make this 26. 11 plus 5 is 26. And negative 2, x plus 5 times negative 2 equals 21. That's a negative 10. I would have to add 10 to both sides. That would make my x a 31. So those are all ordered pairs, 21, 0, 16, 1, 11, 2, etc. Those are all solutions to the linear equation. Okay, next one. Fractional coefficient. Yuck. We don't want those. As much as we can do to get rid of that, I want to do it. So I'm going to put a number in for x. I'm going to start with 0 because that's going to give me a 0. 2/5 times 0 is 0, plus y equals 11 means y equals 11. So that was easy, like that. If I put a 1 in, like we have been, I'm going to get 2/5 plus y equals 11. Then I have to subtract 2/5 from both sides, and that doesn't sound fun. Getting the same denominators. Can we avoid that? Well, yeah. If I can make my 2 into a multiple of 5, then we're golden. So let's try 5. Let's put a 5 in for x. That's 2/5 times 5 plus y equals 11. Well, 2/5 times 5 is 10/5, which is 2. And that's nice, a whole number. I can just subtract 2 from both sides. I get y equals 9. What about 10? If I put a 10 in there, that's 2/5 times 10 plus y equals 11. Well, that's 20/5, and 20 divided by 5 is 4. So subtract 4 from both sides, I get y equals 7. So we're just trying to get the fractional coefficient cleared out of there, and that makes things much easier. I can certainly do it with a 1 or a 2, but I'm going to make things a lot tougher on myself. How about some negatives to make sure? How about a negative 5? 2/5 times negative 5 plus y equals 11. Well, that's negative 10/5. Negative 10 divided by 5 is negative 2. I would have to add 2 to both sides, so my y would be 13. Negative 10. 2/5 times negative 10 plus y equals 11. Well, that's negative 20/5, or negative 20 divided by 5 is a negative 4. I would have to add 4 to both sides, so my y would be 15. And there's some of the possible infinite solutions to that equation. All right, and then lastly, at the store, you see that you can buy a bag of candy for $2 and a drink for $1. Assume you have a total of $35 to spend. You're feeling generous and want to buy some snacks for you and your friends. Write an equation in standard form to represent the number of bags of candy, X, and the number of drinks, Y, that you can buy with $35. Well, remember, standard form is AX plus BY equals C. So I want my equation to look like that. And I know that a bag of candy costs $2, so 2 times every bag of candy, X, plus $1 times every drink is equal to my $35 that I have to spend. So there's the equation in standard form. And then, like we had previously, we could find solutions by substituting a value for either X or Y, and then isolating the remaining variable. All right, that is lesson 12. I hope that helps. See you again next time.